Hello, I'm JW. This time we're going to have a look at how you'd wire up motion sensors, so that's the PIR or passive infrared, but it also applies to other types like microwave sensors and also the lux sensors that just turn lights on when it gets dark and obviously turns them off when it's daylight. So all these things wire up pretty much the same way. So we're going to have a look at how that's done and also how you could wire in an additional switch for an override. So you could have the lights, say, turned off and not work at all. Obviously it's useful for maintenance or whatever. Have them turn on so they only work on the sensor, but then also have another switch or another combination of switches so that you have them on permanently if for some reason you wanted them to be staying on for an extended time. So there's a couple of ways of doing that. Have a look at these and the diagrams for that. And I've also done the diagrams on the website as well, so you can find those at flameport.com. Link to that in the description to this video as well. Now, in terms of what we're here, this is a photocell or a light sensor, and the deal with these is that this is the actual sensing part. 3 terminals on the bottom here, they go into this socket arrangement here, and this is the wall bracket for the socket, and then just got 3 terminals on the bottom there to connect the wiring to the circuit. And these ones, they just turn the lights on when it gets dark, and then turn them off again when it's daylight, so fairly standard item there. And you can actually place the top here separately, so if this breaks you can just swap it for another one without having to change the wiring. And in terms of the actual connections there, what we've got is pretty typical for these and the other types of motion sensor as well. So we've got line and neutral connections there, and those need to have permanent power so that the thing actually functions. And then the third connection is the switched output, so all that happens there is that when the lights are off, this isn't connected to anything, and when the lights turn on it just connects the line and the output there, so essentially like a normal switch. 2 terminals not connected, or they are connected, so it's just your output there that will go to your lights. And this doesn't have an earth connection, as most of these things don't. However, you do need to bring an earth connection to the actual fitting here, as that's actually a requirement in BS7671. In terms of assembling these, this goes on the wall somewhere. This is just a cork gasket there, which just fits in like that. Wires come in the bottom, just put a sort of cable gland there, just a piece of flex or whatever coming out. That just sits in the top, and then there are screws which secure that in position. And then the top just plugs into that socket there with the 3 terminals, so it's just place in and twist. And you'll see that these are different sizes, so it only fits into the top one way round. So essentially that will go in like that, press down, and then it just twists and locks into position. Now that was a photocell there, just senses the light level and switches things on and off when it's dark. In terms of the motion sensors, there's 2 common types there, one of which is the PIR, which is passive infrared, and then the other type is a microwave. Both wire up in exactly the same way. The difference between these is that the PIR is what I'll call the more traditional model. The word passive indicates that it doesn't actually send out anything into the environment. All that happens there is that if there's an object moving in front of it, which is emitting infrared, so that's like a person or anything that's sort of heated compared to the background, then that infrared radiation goes through the front and is detected by a sensor chip inside. And the way they're configured is there's a set of lenses on the front, so that as an object is moving and it's emitting infrared, the infrared goes through 2 of the lenses and it apparently moves across the sensor inside, so it can detect very different. So although they have sort of regions where you can obviously walk through and it will detect that, it's not sending out beams of anything. It's purely the warmth or infrared radiation coming off of a person or an animal or whatever else, including things like cars obviously, because they also get hot. That just goes onto the sensor and it's detected. So passive infrareds only detect things which are warmer than the background, so they're not going to detect normally things like trees and leaves blowing along in the wind, because generally they're going to avoid the same actual temperature as the background. And for this reason these are normally suited to use outside, so obviously you only want to actually activate it when there's, say, a person there, or say a vehicle or something like that. Microwave sensors on the other hand are not passive, you might call those sort of active. As a microwave sensor does actually send out a signal into the environment, it's in the microwave region, and then it looks for the reflections coming back from that, and if you have something moving then it can detect that the signal coming out has changed slightly. So a microwave sensor will react to anything that's moving, whether or not it's the same temperature as the background. So generally using a microwave sensor outside is a bad idea because it will literally react to everything that moves, including a tree or a hedge moving about in the wind, or pretty much anything else. So if that's what you want, well, absolutely fine, but generally that is not what you're going to want at all. But say in terms of wiring these up, they all work pretty much the same. Another warning about the microwave ones is that because it's a very high frequency radio signal that's coming out, it can pass through things like glass, and it can also pass through thin doors and even certain types of wall as well. So if you put one in, say, a hallway, you may find that walking in the room next to it actually will trigger the sensor as well, just because the signal can actually pass through the wall and still be reflected back. And if you stick one on the ceiling, yes, it can actually go through the ceiling into the room upstairs and various other annoyances. So just be aware of that with a microwave type. And say the passive infrared is ideal for outside, but again, only reacts to heated objects, so no good if you just wanted to react to anything that was moving. Now, a fairly long time ago, and you could actually buy passive infrared detectors, and normally they were attached to those dreadful 500 watt floodlights, and they had a sort of an override feature built in. And the deal was that if you turn the switch on and off, say twice in quick succession, then the light would stay on permanently until you therefore turned it off again. But those things aren't particularly common now. In fact, I've not seen one for many years. And certainly if you're going to say buy things like a separate sensor, then typically they don't actually include that feature. And of course, even when they include it, it was a bit rubbish anyhow. And one problem with that is if you had a bit of a wonky supply, say you lived out in the country or something, if the supply was interrupted for a fraction of a second, then it could actually result in your outside lights staying on all day and didn't want them to. So that was a kind of an override feature, but it was a bit rubbish, and so I don't seem to make that type any longer. Now, of course, you can buy floodlights and the like with the sensors built in, and those may be suitable in some cases, but in a lot of instances they're not a particularly good solution, because quite often you find that to get the sensor covering the area you want, it generally results in the floodlight blazing horizontally or even up in the sky, and if you put the light sort of pointing down at the floor where it should be, unfortunately the sensor also does the same, so it doesn't really work. So what we're going to show here is how to do it with a separate sensor, but nevertheless the same principles apply to one with it sort of built in, assuming all the terminals are available. So first of all then, obviously there's the sensor itself, so we'll just draw that in over here, and typically it's going to have 4 terminals inside. We'll call this a PIR sensor, but if it was a microwave or a photocell, exactly the same. So line of neutral, which is going to be the permanent supply, so obviously needed for the thing to operate. There'll be a switched line output, and this is the one which is activated and connects to the light or lights that you've got. And normally there'll be some kind of earth terminal inside, although most of these are made of plastic, so they don't actually need it themselves. It's just there to provide that sort of termination for the wire. So that's how we've got that. In terms of what you can do inside, there's a couple of choices. First one we're going to show is if you're going to use 2 switches. So what you would need there is a normal 2-gang switch on the wall. So we'll draw that in. Now what we've got here is a 2-gang switch, and this is also a 2-way switch. And what we're looking at here is the back of it, so these are actually the terminals on the back here. And just a quick reminder how these work. You've got your common terminal at the bottom here, and it's either connected to, say, that one. When the switch is in the position, it's connected to that one over there. So it's either these or these, and then the same with that. It's separate to switch those or those. Those two are never connected together. If you're going to do this behind the switch box, which is probably recommended because that means you only have a single cable to the light. A lot of lights, as if you fitted these things, you'll know that when you come to put on the wall, there's really only room for a very small amount of wiring in the back, so keeping the wiring at the actual light fitting to a minimum is generally recommended. And the same can apply to a lot of the sensors, they only have a very small amount of space. So we'll do all the wiring behind the switch box here. Now in terms of the incoming supply, we're going to need a couple of extra terminals, so we'll just draw that here. And another one here. So that'll be for neutral and the earth connections. And incoming supply, we can have that coming in like this, so the earth will go into the one like that. And then our neutral supply can come in to a terminal here. Those can be screw blocks or the Wago or whatever connectors you want to use. Now the incoming line we can actually bring into the common of one of the switches there. And what these switches will be is one of them will be on and off, so it's off, nothing works. On, it can either be overridden or on the sensor. And then the second switch here would be for automatic operation, so it only works on the sensor, or permanently on if you obviously wanted that. Now I'll just quickly draw in the other wires here. So from here we're going to have a cable going over to the sensor there, so the earth wire there, that will just go over to the earth terminal, fairly obvious there. We also of course need a neutral to go to the sensor, because otherwise it won't actually work, so I'll put that straight in over there as well. And in terms of our light or light fittings, we'll just draw one of those here. And again, they're going to have the same connections in there, so just 3 of those. And again, you could extend this to more light fittings if you wanted, just draw one in this case. So neutral for the light, again, that will just come across straight into the neutral terminal. And again, our earth wire will come across to the earth terminal for the light as well. So nothing particularly surprising there, it's just connecting the neutrals together, connecting the earth together, and those will come in from our supply, which is over here. Now the lines is where the actual more involved part is, though it's relatively straightforward. So at the moment we've just got the supply coming into here, so that this switch here can either come out here or here, depending on what we want. So we want an off position, so we're not going to actually connect this terminal to anything, so when the switch is in that position nothing is powered, so that will be the everything off choice. And if in the on position we want the actual PIR sensor to have some power, so we have one wire from here and that will go over to the line input on the sensor. So when that's on, which would basically put a wire between here, sensor has power and also will operate and hopefully sense things if it was going past. Now the next thing we need is to connect the output from this sensor here, and we need to actually connect it over to the light. Now we could just shove it over to the light there, but of course that's not very practical, because first of all that would just be a single floating about in the middle of space, and also we want that override feature. So when the sensor detects movement, this will be switched onto the line there, so basically those two link together. We can actually bring this one back. We'll bring it back to the terminal of this switch over here. Now what we've ended up here is 4 cores here, so that is basically one cable. Certainly for smaller, say, domestic type installations, that would be a 3-core and earth type of cable. Just the 3 there, and then the earth as the CPC as the 4th conductor. Now if this is actually switched on, of course we need this to connect to the light, so this one is where the other wire from the light would connect to. So line in the light there, I can come back and connect to that same terminal there, and it's perfectly fine to put 2 into the same switch terminal. Most light switches will easily accept 2 wires there. So in this configuration, this switch doesn't actually do anything at the moment. Earth and neutrals just connect through to the relevant places, and again the cable here we've got is just a normal 3-core cable, or twin and earth, whatever you want to use, so line, neutral and earth there. The sort of benefit of the light fitting, you've only got that single cable, and if you wanted to go to another one, it's just extend those 3 to another light fitting, and then you run it with 2 at each light fitting, which again isn't too bad to fit into the back of most of them. So with the switch off, nothing actually works. With the switch on, power goes to the sensor. If the sensor has detected movement, then that comes back here and just goes out to the light fitting, so no problem with that. If that's all you wanted, you could actually just connect these inside with another terminal block, just have a single switch, absolutely fine. However, we want an override as well, so this switch here we can actually use as an override just by adding an extra piece of wire. Now to have this on permanently, what we need to do is to connect the light fitting here, the line, to the supply permanently, and we can actually use this switch for that. So what we can do is connect from here to here on the back of the switch, so just linking the output there to the input of this one. So again, with this switch off like that, nothing is actually going to work, so no power gets to anything. However, with this is the on position, this terminal here is also permanently live as well, so that this switch is now the override. So in this position, this is only connected via the PIR sensor, but if we just move the switch over to this position, this piece is now connected to the incoming supply permanently, and that's your override. Notice it also connects that to the output of the PIR, but again that doesn't matter because that's only a switch line anyhow. So then this switch becomes on and off for everything, and this one becomes automatic when it's the sensor, and basically on all the time. And so you can do all of this in the back of the switch. Normal 2-gang switch, link between the two wires at the top there, and then just the extra terminals there for the neutral and the earth or CPC. And the other benefit of doing this with a separate sensor is you can put the sensor in a different position to the light, because in many cases you want people to be walking across the sensor so it actually works correctly, but that doesn't necessarily mean it's also the same position where you want the lights to be fitted, so they can go in separate locations. And of course you can also have multiple lights as well if you wanted. So that's how to do it with two separate switches. A fairly common arrangement. 2-gang switches are pretty much available everywhere and very commonly available in pretty much any style you would want. Now another way to do it is to use a single switch. So let's just draw that switch in here. And this switch is what's called a center off with 2 positions. So it only has a single actual switch on the front there, 3 terminals on the back. Draw them in a line there. So basically you've got common, L1 and L2. And the deal with these switches is they have 3 positions. In one position, common and L1 are connected together. Then it's got a center position where nothing is connected together. And then in the bottom position, common and L2 are connected together. So it's similar to a normal 2-way switch, but it has that additional center off position where nothing is connected. So of course the center off position is the position we're going to use here for everything off, and then we've got one position at the top for on the automatic sensor and one at the bottom for manual override. These types of switches are not as commonly available. They're normally available in a sort of a grid arrangement where you buy the switch and the plate and everything separately, but nevertheless they can be found, and certainly is a bit of a more tidy situation if you just have a single switch rather than 2 of them. Now just as before, we're going to need those extra terminals for the neutral and the CPC there, and we'll have our supply coming in here just as we did before. So again, as before, the neutral just comes into the terminal at the back of the switch there, and the CPC or the earth comes in to the terminal there as well. Now in this particular case, the line coming in goes to the center or common terminal there. Now we'll just draw in the PIR sensor there. So we'll do this as we had it previously. So the CPC is to basically just go through to the light or lights, and of course the other one goes over to the sensor we have over there. And again we'll call that a passive infrared version, but microwave, whatever else, all works the same. Neutrals again just go over to the appropriate neutral terminal in the light there, and also over to the neutral on the sensor. So that's again exactly the same. Now in this particular case we want to again have power going to the sensor, but we don't want power going to the sensor when it's in the automatic position. So if we say that the top position here was auto, so we have the power coming out of there on the line, and then that will go over to the supply to the sensor. So when the switch is in the up position, those 2 are connected, power goes to the sensor, so the sensor operates, and then when obviously it detects movement, this terminal here becomes live, and that's the one we want to go over to our light. So yeah, we could just put it there, but that's not going to work in reality. So what we can do is bring it back to the box, and we can use the L2 on the switch just to join that together. And of course we need to come from L2 then over to our light or lights that we have over here. Now this is actually the complete circuit including the override. So just as we had before, this here is one cable, probably that 3-core and earth or 3-core and CPC type of thing. And again this here is again one cable, just the 3 cores in it, so it could be that twin and earth or just flex or something like that. So the way this works is that when these 2 are connected together in the up position, supply comes in here, powers up the sensor, sensor detects movement. When movement is detected, this are linked together here. Power comes back on the wire here. We're just using this as a basic convenient terminal to connect together, and it goes back out to the light or lights, and the lights turn on. In the center position, nothing is connected here, so power doesn't actually go anywhere, just stops there. So the sensor doesn't work and neither do the lights. And then in the override position, which is the bottom, these two are linked together. So the power's coming in, goes onto this terminal here and goes straight to the light, so that stays on permanently. Now in that position, if we just draw that in, the sensor supply isn't actually connected to anything. However, the switch line here is. Now this isn't a problem on the vast majority of sensors, because on most of these they actually have a relay between here, and of course if there's no power going in on this, then there's no connection between this and any of the other parts. Now there are electronic sensors, or there certainly used to be at one time, they're not particularly common now, so in a very rare cases it might cause some problem if you connect it here and it was one of the electronic switching types, but that's highly implausible because basically these are live terminals anyway when it's in normal use, so 99% of the time that's not going to cause any problem. And certainly if it's got a relay inside, and you can tell it's got that, so when you move in front of it you'll hear the relay click on and off, that won't be a problem at all. But just mention that there might be some weird sensor out there where if you just connect one and not the other it might cause some kind of problem or even damage it, but so I think that's exceptionally unlikely. So just as you had the other one, all of this is essentially in the back of the switch inside the house. A single cable coming in, cable goes out to the light or lights, and then cable goes out to the sensor. And again, you can put these wherever you're most convenient and appropriate, rather than having them stuck in the same position and neither of them particularly working optimally. So let's look there at wiring up a sensor, and it doesn't have to be any particular kind of sensor, so they all wire up pretty much the same. It's just a power supply and the switched output, so microwave, passive infrared or the photocell, all pretty much the same. And it doesn't have to be outside either, that can also be used for things inside, so if you've got a room with a microwave sensor in it, then absolutely fine to use the same arrangement. So obviously it's automatic, off or on permanently, although certainly inside, if you're going to put that in, I'd suggest putting the override switch somewhere else, or at least with like a key or something, so that you don't have people turning it on and leaving it on, because of course that would obviously kind of eliminate the point of having the sensor in the first place. Now pictures for this, things are on the website as well, so say a link to that in the description, and they're obviously somewhat better drawn than those hand-drawn things we just looked at. And final point there is about the type of the sensors there. Microwave sensors are generally better for use inside because they only react to things moving. If you put a passive infrared inside, there is a problem there because say I had a radiator on the wall, when the radiator heats up and the warm air starts rising off of it, that can be easily enough to trigger a PIR sensor, and of course that would work when nobody was in the room, whereas microwave ones are not actually sensitive to that. And conversely, you don't normally want to put a microwave sensor outside because it literally reacts to anything that's moving. So if the wind blows and say a dustbin fell over or something, or the trees or whatever moved, then it's going to be triggering all the time, and that's going to be really annoying. So passive infrared outside is much better because then it only reacts to warm objects moving, so people, animals and vehicles and so on. And you can use either in any place, but generally it's better to do it that way round. So that's it for this video. Until next time, thanks for watching.